Hello everybody, welcome to CIS101. This is Bob Hendry and this is Tuesday's class on November, Tuesday, November 13th, 2018. So this is our virtual class for today. So what we're going to do, what we're going to do today is we're going to learn more about Java, and specifically we're going to go into our sandbox and to learn more about programming with Java in our sandbox. So I'm going to continue with that video. I'm going to break away and go to the pre-recorded video, which I did just about an hour ago. If you have any questions, you know where to find me. My email address or my phone number is 630-965-6526. Thanks a lot, folks, and enjoy the video. Hello everyone, welcome to our virtual class. I am Bob Hendry, and let's get started. First of all, I want to mention I got these pop-ups that kind of come up from Google, so I apologize in advance. I'm going to kind of close them as they kind of come up here, but I need to shut those off. It's kind of annoying. All right, so this is what we're going to do today in our virtual class. We're going to continue with Java. Now again, we're going to have Java just for this week and maybe next, and we're going to move on to other things as we kind of get into the main stretch of our semester. So our goals today is we are going to learn more about Java as a program. We're going to sharpen our skills in writing Java code and debugging Java code and just writing some basic Java programs. Now remember, my goal for you is to get a basic understanding on how the language works. So we're not going to have a real deep dive into this. I'm going to save that for another course. If you take another course, say that 10 times fast after a martini for lunch, right? So we're going to cover this in more depth in an object-oriented class. If you're interested in taking this further, let me know. I can tell you which course that you should sign up for. Again, I'm just trying to give you the basics and of familiarity on how Java works. Now, previously, we talked about Java as an application and as a platform, where we went over kind of about like how different languages are used for different things, and Java certainly is used for specific things in software development. And also, just as a review, we already went over about how different languages are used to leverage different sorts of environments. It's not really a one-size-fits-all thing. Sometimes you go into different blogs, into different chat groups maybe, and you always get inevitably, people that like one language over the next, but don't get caught up in that. Like I mentioned before, different software languages are kind of like going to a home improvement store like Home Depot and buying different things, buying different tools. I mean, you buy screwdrivers to do screwdriver things, you buy hammers to do hammer things, and you buy levels to do level things. Just like languages, you use different languages for different things. So I'm not going to really get into the argument or discussion about what's better than something else, because I look at those discussions and it's kind of like saying, what's a better tool I should use, Bob? Should I use screwdrivers, or should I use hammers, or should I use wrenches? And I'm thinking about the question, and I'm like, that's not really a question. It depends on what you're trying to do. It depends on what your skill set is, and it depends on what your end goal is. I mean, it's almost like saying, I'm going to paint my room, what color? And someone like me would say, well, what color do you want? What color do you like? And what color paints are available to you? And other parameters like what do you want to match it to? You want to match it to furniture, carpet, all these other things. So a lot of that has to do with languages. So don't get caught up really too much in, we learn Java, we should learn C#. Well, you probably should learn both, depending on what you want to do. And again, we're going to, for the remainder of class today, is stick with some OO concepts. Because I mentioned before that OO concepts are used pretty much in defining how you build OO languages such as Java and OO languages such as C#. So we're going to stick with that. Now, this is what we have here. We have in our program, again, we're using our sandbox, which is www.compiledjava.net. And here it gives us a way to program Java code. Now, we can't have an interactive Java command line, but What we will do is we'll just be able to pass in maybe some static parameters. So this is what we have here. Let me get rid of some comments. And actually, let me change some comments. Now here we got one class needs to have a main method, and it does. And I'll also put in another comment saying this is our class block. Now, Java programs have what are called blocks. Now, a block is denoted by an open brace, right, and a closed brace. So when I highlight this guy here and this guy here, this is basically defining what our class block is. Now, all Java programs start with something like this. Java programs are called class files. Now, again, we went over the differences between like classes and like instances. Now, what is a class? A class is a blueprint. And for example, if you go into any of these subdivision communities, like for example, you're driving through Naperville, you're driving through Yorkville, pick one. You might notice that a lot of these tract houses, and again, if you don't live in the city, you don't get this because in the city, every house looks like it's kind of slightly different. But if you go into some of these cookie cutter used to be cornfields and you look at some of these houses, I mean, basically what happens is you get, in the houses that you look at, you notice that a lot of these houses are the same. That's because they were built from the same blueprint. A blueprint defines what a class is eventually going to look like and what it's about to do or what it is able to do. Now, I'm being kind of vague on purpose because a blueprint is kind of vague if you think about it. If I handed you a blueprint for a 2,000 square foot ranch home that you're going to build, presumably, it's really just a bunch of documents that describe stuff, isn't it? In reality, it's a piece of paper, and that piece of paper just describes about the house. It says this is how big it's going to be. Here are the elevations. Here are the rooms. Here are how big the rooms are going to be. And then it's going to have some different engineering documents, what the air conditioning is going to look like, what the plumbing is going to look like, how to wire the house, how to put in things such as garage doors and all this other good stuff. That's all part of the blueprint. But if you were an architect and someone said, well, what is the blueprint? You would say, well, really the blueprint is physically just a piece of paper with a bunch of writing on it. And then the person answered the question would say, well, that doesn't make any sense. It's got to be more to the blueprint than that. And you would say, well, there is. The blueprint describes how we're going to build the house. And then you probably would understand that. You'd say, okay, well, I get it. It's directions, it's instructions. It defines what the house is. But if someone asked you, as an architecture student, looking at a blueprint, said something like, you come up with the definition of a blueprint. And if there's 30 engineering students or architecture students, you probably would come up with 30 different definitions. But all of you would agree that it just kind of describes what the house is, what it does, how it's built, and all that other stuff. But you would vary a little bit from that description. Now, that's exactly how class files work when you're dealing with software engineering and you're dealing with OO programs. The class file is a blueprint that describes what the program does. Now, again, that's extremely vague, and it is, just like it's vague when you describe what a blueprint for a house is. But anyway, there are different constructs and different properties that describe a little bit more detail about a class, and again, a Java class. Now, again, when we talk about class files, it works the same in any OO language. Class files work the same when you're dealing with C# or any other object-oriented language, or we call in the business OO languages. So one of the things is public classes or classes have what's called a modifier. Now your modifier or your accessor determines who has access to this class. Now I'm going to be very quick through this because I'm not going to go through all the details of this. I'll leave this to your instructor that does Java as a 16-week course. But since we've broached this, we can talk about this a little bit. Different things can access your class. Public, that just means that any thing or calling program, that needs to access this Java program anywhere can access it. It's public. It's just like a public building. Think about walking into City Hall or walking into a post office. It's public. Anyone that knows where to find it can walk in and do their business there. Now, we also have other accessors. We have private. Private would be analogous to, how about a room inside of your work? You work in, I don't know, you work for AT&T out on the north side of Chicago. Now, or you work for Northern Trust Bank or a bank. Let's say you work for Northern Trust Bank. I'm not picking on Northern Trust, but anyway, I'm looking out the window and that's what I'm seeing. And let's just say there's a vault in the basement, and that's a room. Now, the access to the room might be private, meaning that only people that could A, get into Northern Trust Bank, and B, have access to that room should be able to get there. That's what a private class would be. Now, you also have what's called a friendly class. Now, a friendly class is analogous to maybe your work. You work at Verizon Wireless out in Rolling Meadows. So you have a key card that lets you get into the building, and once you're in the building, you could access things such as the lunchroom, the mail room. That would be friendly access, meaning that only, if you're allowed within that class, you could pretty much have access to these different rooms. That's called friendly. And you also have protected. Protected is kind of like friendly, but a little bit more restrictive. Like, for example, protected class might be getting into your work at Verizon, where you need to get a fob or a key card to get you past security or get you through the turnstile or to get the elevator to work. That would be protected class. Anyway, what does this mean to you? It just means that different classes in different OO languages have different accesses that you could use to get to them. Here we're using public because we don't care. We're just making it public because we're really illustrating different points. Now, your Java program has different ways that you could get into it. The main thing that you can get into is is your main method. And I'm going to put in entry. Pardon me. Again, I'm not responsible for these pop-ups. I have no idea where they're coming from. I need to turn them off, but not right now. I'm going to put an entry into the Java class. Entry into the Java class. Now, I'm going to kind of delete these here. Entry into the Java class. Again, this is the main method. And the main method is where your program actually starts. And this might be somewhat of a review, and that's fine. If it is, it is. Like I said, it's our goal for Java isn't to determine how much we cover, because we can't cover a lot of it in just a short period of time. So if some of this is repeat, I don't apologize for that. That's fine. If we're re-emphasizing previous points, so be it. If you're going to go in the languages, you're going to have all the time in the world, trust me, to kind of sharpen your saw a little bit. So your main method is your public entryway into a Java program. This is where it starts. When you execute this program from somewhere, right now we're still kind of building our blueprint, right? But when we execute our blueprint, we need to start somewhere. And that starting point is your main method. Now, your main method also has some really different things here, or some things that need to be explained. Now, your methods, or your functions, are the same thing. You should know what a function is, by the way. If you're, have a high school education in math, or hopefully by now a college education in math, you should know what a function is. A function is basically, a group of statements that do something, that add two numbers, that give you the raised percentage of something. You figure out what it is, but you define what functions are. Functions have predefined inputs and outputs. For example, we pass two parameters into a function and it passes a value back, like a function that add two numbers or what have you. Now, again, the concept of a function, or they're called methods in OO languages, they're really meant to be the same thing, or meant to mean the same thing, are not really a construct of object-oriented languages and of course of Java as well, but they're mathematical. I mean, if you have done anything in math at the high school or college level, you know what a function is. Also, if you've done things in Excel or written macros in the Microsoft Office suite of products, you're familiar with writing functions and writing macros. A function, or again, known as a method, and we use those terms analogously within writing a Java program, and certainly within writing an OO program, are meant to be the same thing. So anyway, our main method has our accessor, or our modifier. It's public, meaning that this main method is accessible to any other calling program that could run this program. Again, it's a public method. Don't look too much into it, except that anyone can access this and run this if they know where to find it. Static. And again, you don't need to write notes down for this, because I'll leave this to your Java instructor, maybe me, in a later class. Static just means that there's only one of them. Now, what does static mean as far as a blueprint goes? Let's just say, for example, we're writing a blueprint for a house. Something static might be something that's defined once for a blueprint and only once. Like, for example, we might have the builder. That would be a good one. Let's just say the builder, I am building a subdivision in Naperville somewhere, and I'm Bob's Builders, right? Bob the Builder. If you have children, you know who Bob the Builder is, or maybe grandchildren at this point. I don't think Bob the Builder's been around for a little bit. Maybe he is. But Bob the Builder is our contractor for building all of these houses. Now, Bob the Builder is going to be the same across any sort of class that I build, right? Let's just say that I have different blueprints for different houses. I have the blueprint for, well, let's just call these models crappy house, okay house, and nice house. Now, if you ever went shopping for a house, they got, cooler names than that. Like, we have the Armstrong version at Babbling Brook or something, and that's the premium version with the whatever and the granite countertops. And then you got the houses that I can afford, which is like a crack house, down by the van, down by the river, if you're used to Chris Farley. So let's just say that I have different classes that are different blueprints for those houses, but they're all built by Bob the Builder. Bob the Builder would be something that would be considered static, which means Bob the Builder will be constant across all of the classes, because all of the classes and all the blueprints that Bob does are going to be Bob the Builder. There's no other builder. There's Bob the Builder for class 1, 2, and 3, or blueprint 1, 2, and 3. Now, in computer languages, there's a word for that, and that's called static. And to get further into it, if you want to be alpha geek, it's called a static modifier, which means it's only there once. Bob the Builder is the builder for all of our classes. The main method here is only one main method for any of the classes that we're going to build. Now, if that is clear as mud, fine. That's all right. Like I said, I'm going to leave that to your Java instructor. Void. Void means that this function doesn't return anything. It means it does something, but it doesn't return anything. For example, we're going to write a method that does return stuff. Not here. Not in the next 5 minutes. But here we're saying the main method doesn't return anything. And also, the main method takes in, as its arguments, again, we pass things into a main method. In this case, we're passing in an array of strings. Now, an array is denoted by the open and close bracket. That's right. Which means that we have many strings that can be passed in, and we're calling them args. Again, I'm just trying to show you the basics here. If a lot of this is skipping by you, I wouldn't worry too much about this. If you get through our Java portion of the class and you scratch your head and you're like, all right, I think I got a beginning square one, step 0, step 1, step 2 feeling of Java, a lot of the stuff is fuzzy, you're fine. That's what your objective is, and you're okay. You're not going to be responsible for this on your final. You are going to have a lab on this, but on your final, you're not going to be responsible for any of these questions at all. I might give you like one question on Java and ask you like what the value of a variable is. There'll be very simple questions. I don't expect you to be an expert. The reason I keep mentioning this is I'm trying to talk you guys off of the Triton water tower, because some of the emails I've been getting, you guys are just completely freaking out about this stuff. And that's fine. Like you guys know me. If you're freaking out, it means you care, right? It means you're paying attention. It means that you're caring about what you're doing. So if you're freaking out, continue to freak out, but I'm saying it will be okay. Walk towards the sound of my voice. Walk towards the light. It'll be just fine. All right. So anyway, everything that we do is in our main method. Also, I got to point out, don't be careful. Don't refresh your page. You're not really saving this. This here is not like things that we've done in Oracle Apex where you save this as a script. This is not a script. You are literally typing something in a web browser, and when you refresh your browser, your stuff goes bye-bye. So if you want to save this, I highly encourage you just to paste this into Notepad and save it in Notepad, and you guys know what to do. Just save it in Notepad, put it on your thumb drive, email it to yourself. It doesn't really matter. Just make sure that you save it, and if you refresh your page, you know you're going to get rid of your stuff. But anyway, at this point, we're going to write out to the system. We're going to put in system.out.println. And again, maybe a review. And we're going to say I had it, print line. And we'll put in, again, this makes it look familiar. Bob is lame, but this class is cool. Now, all of this does, and again, don't worry and do oohs and ahs about what it does, because again, we're kicking tires here. If we're at a dealership, we're just looking at cars and we're looking at what they do and just kind of playing with them a little bit. So here we can run this program simply by going to compile and execute. Make sure that we're still running there, and we are. And we should see the output here. Bob is lame, but this class is cool. I'll give you guys a second. And what I will do is I'll email you guys the code. So believe it or not, you are your own Java programmer now. Now, does it get more complicated than this? Well, of course it does. It's just like if we were learning the English language or whatever your native tongue is, Spanish or Russian or English. We have a lot of languages in this class. We're just learning a few words. But more than that, we're learning the system of how the language is constructed. Like for example, if like in Spanish, if you were learning to speak Spanish, you probably don't learn just words. You learn how to you learn the differences between, like for example, nouns, and you have feminine nouns and you have masculine nouns, like with el and la. And then you have like perfect verbs where you have, hablo, hablas, hablamos, or hablan, where you got, me, you, formal, you, informal, all of you, and us. So, when you learn those different languages, like in Spanish, you're not necessarily learning words, you're learning how to construct them. And then that's kind of what we're doing here. We're learning a little bit of each. We're learning how to construct a Java program or an OO program, and we're learning some of the specific words as you go. And then, like I mentioned, like if you're learning Spanish, you learn the verbs, and then you might just say, okay, well, now that I got the verb and like regular verbs and irregular verbs down, now I can just spend time learning nouns, like looking around the classroom and looking, at doors and windows and puertas, ventanas, and sillas, mesas, and just go around and just mentioning what the different nouns are. You kind of learn Java like that, where you're going to go back and forth with how the language is constructed and how to do things, and then specific, like what's the word for this, what's the word for that. It's not that much different. So anyway, I got Bob is lame, but this class is cool. Now let me show you about this stuff that we're passing in. Now we got, again, different values that we could pass into our main method. Again, here we got like an array of strings. All this means is from the command line. The command line is, your DOS prompt or your PowerShell prompt, or you guys have seen, or like a SQL Plus prompt. That's your command line. When you execute this program, you can pass in string values, and they're denoted by args. Like, for example, we're going to put in here, going to put a comment, and we're going to say get the arguments. Arguments are just parameters that are being passed into the program. You put passed into, pardon me, I know it's annoying, into here. So we're going to declare 3 variables. We're going to declare a string, and we're going to call this one, I don't know, we can name it anything we want. It's our variable, parameter 1. And we denote it by the suffix, semicolon, and then we'll do string. And we'll say this guy's called parameter 2. And we'll say string parameter 3. So I'm going to pass in 3 parameters just because I can. What are they going to do? What's the deep meaning? There isn't none. I'm just passing in parameters just to show you how we could pass in values. Now, what can they be? They could be names. They could be anything, but they have to be strings. Now, you should know the difference between strings and numbers at this point, so I'm not going to go over that. So we're going to say, how about this? Parameter 1. Pardon me. Is equal to args 0. Now 0 is actually the first number in computer science. 0 is actually a number. This is the 0th element, which means it's the first one. You don't say 1, 2, 3, and 4. You say 0, 1, 2, 3. So our first argument is args, because that's the name of it that we're passing in, and we're getting the 0th element. And we're going to do the same for parameter 2 and 3. So we'll say parameter 2 equal args 1. Whoops. And by the way, we're programming our main block here. And we'll say parameter 3 equals args 2. So we're passing in 3 values, and we're just capturing those values, and we're putting them as we're capturing them in our main method. Why? Just because we can. Remember, there's no real saving here, so be really careful. While you're doing this, you might want to do a compile and execute. And you should get, oh, this is good. You're getting Bob is lame, but this class is cool. And you're getting an error. Let me explain what this is. Now, don't worry about this too much. You're getting an array index out of bounds exception. That just means that it's expecting to get some values that we're passing into it, and it's just not finding them. So that is an exception. And you're going to find out, again, I'm glad we got this error message, that when you do OO programming, error messages are called exceptions. So one thing that you're going to learn as you go through your OO language career is you're going to learn how exception handling works. Now, we're not going to talk about it here because it's an intermediate topic. But even if you go in the C#, you're going to talk about exceptions. Java has exceptions. Power Builder has exceptions. C++ has them. All OO languages do. All right, anyway. So I'm just going to write these out to the command line. I'm going to put in system dot out dot println, and we're just going to write these out. We're going to say hello, which is just, a string. We're going to put it in there, hello, and then we're going to append, which is the plus, parameter 1. How about append another string? Parameter 2. Let's append another string. Parameter 3. And I'll give you a second to kind of either pause the video and get this all squared away or kind of catch up to me. All right, now, what we need to do now, and again, this will take a step back. What we're doing is we're programming everything in our main block. So now we need to put in the command line arguments. We're going to put in Bob, then space. We're going to put in Cassie, space. Then we're going to put in Fred, which is our raccoon. That's our kind of unofficial pet. We have a raccoon that comes to our door and we feed him. He's as big as a house. I'll take a picture of him someday because you swear to God, you're sitting and you're looking outside and there's like a koala bear that crawls across the porch, and that's Fred. That's our adopted raccoon pet. Fred's really friendly too. You can actually walk outside and on a good day put a glove on and actually pet him. I'm afraid to do it without a glove on, because if I get bit, I don't want to go to the hospital at 1 o'clock in the morning to get rabies shots. But Fred's really friendly. So anyway, I'm passing in Bob, Cassie, and Fred. So when I execute the program's going to start executing at the main method, because that's what Java programs do. And then we're passing in 3 arguments, and we're getting them here. args0, args1, and args2. All right, so let me run this program. So I'll do that by issuing a compile and execute. And nothing works the first time, but I'm going to cross my fingers that it does. And there we go. Bob is lame, but this class is cool. Hello, Bob, Cassie, and Fred. So what am I doing here? Nothing really too exciting. Nothing horribly exciting here. But we're writing Java code and we're executing Java code. So that's kind of the exciting part that we're doing here, is we're actually writing Java code and executing it. So we're going to continue with this and go in a little bit more detail. So we got this stuff that we're being passed in here. So let's just say, for example, that we're going to pass in these 3 values. Let's compare these values. Let's pass these values to another method. And we're going to do something kind of silly here, where we're going to pass these values to another method, and we're going to have like a customized message for each one. Like if it's Bob, we're going to say something for Bob. If it's Cassie, something for Cassie. If for Fred, something for Fred. So let's do that. Let's get rid of, or at least comment out, the system.out.println, and let's build another method or another function. Why? Well, we don't really have to, but generally you don't do too much in your main method except just get parameters and then just continue processing with another method. So we're going to continue with this by writing another method. On line 19, I'm going to say public static, and we're going to say void. So it's going to be a method that's static, only 1 per class. It's not going to return anything. And we're going to say process names. It's going to take in 3 parameters. A string, which we're going to call N1. We can get to call this anything. Remember, this is just the signature of our method. So we just got to call these something. So we'll say, whoops. We'll call this N1, another string, N2, another string, oh, pardon me, N, N3. And we're just going to do some kind of silly stuff here. And let's build our brace here for our block for process names. And we have our block here for process names. Now, if you want, again, I encourage you to do this, is when you get like just some code here, is always do a compile and execute. And make sure, if you look on the right-hand side, you don't introduce any errors. If you do this after each couple lines, that's fine. Just make sure that you're not introducing any errors within your program. So let's wait a second. And it's taking a long time to execute. It's not really doing much. Taking a while. We'll give it a second. It's not you, it's me, right? There we go. I don't have any error messages, and it does exactly what we thought it would do. It just has the system.out line, system.out print line, Bob is lame, but this class is cool. So we have a method called process names. So let's just do something new here. We're going to be passing in these parameters. So we can say from the main method, we can say call, again, the process names function or method, same thing. Process names. And we're going to pass in parameter 1, parameter 2, parameter 3, and then semicolon. While you're at it, compile and execute. Make sure you didn't introduce any errors. So what we're doing here is from our main method is now what we're doing is we're calling this method called process names. So we're calling this method down here. We're passing it parameters 1, 2, and 3. And again, it has to match the signature here. We're passing 1, 2, 3 parameters. They're of data type strings. Again, just to keep it simple. And we're calling them N1, N2, and N3. What is this function doing? Process names. It's doing nothing right now. But we're calling it. We defined it, and we're calling it. So now what we're going to do is now we're just going to actually have this method do something. And we're going to do something new in here. Rather than just print this stuff out, like for example, we're just going to take the system.out print line. I'm going to take this out. And again, don't worry about getting this perfectly right because you're going to get the code at the end of this demo. So under process names, I'm going to put an if, and you put in a condition. We're going to put in N1 if N1 is equal to, and we're going to put in Bob. What we'll do is in our if block, we're going to say, how about this? I should have kept my system.out print line. System.out.println. Bob is in the house. There we go. So this is a condition statement. Now notice when I start my blocks, I immediately do my start and my end because I don't want my my start and my ends to get all screwed up. So here I got, again, if N1 is equal to Bob, I'm going to say Bob is in the house. So basically, if this statement evaluates, well, it will evaluate to two different values, a true or a false. If it's true, do this. If it's false, it just does nothing. So if this is true, we says Bob is in the house, if N1 is equal to Bob. Let's do a compile and execute. Let's see how this works. Now we got a string cannot be converted into a Boolean. When we do compare, there's a couple different syntaxes that we should try. For example, rather than the first equal, which is an assignment, let's look at the double equals, which is an evaluation. So I'm going to click on compile and execute. And there we go. So let's do the same. Make sure we're calling this. How about we do this? Now notice we didn't get to see the Bob is in the house. Let's put in some debugging stops here. Whoops. I'm going to put on process names, I'm going to put in a debug stop, and I'm going to say function process names is running. And we're going to get this to run, and then I'm going to take a pause so you can catch up, or perhaps pause the video. I was going to say pause the tape, but it hasn't been a tape in a while, and then kind of catch up. So let me do a compile and execute. And there we go. We should get Bob is lame, but this class is cool. Then we got function process names is running, and then we got the comparison. If N1 is equal to Bob, we got system.out.println Bob is in the house. Now I'm going to give you guys a second, about 30 seconds or so of dead air, and you can pause or you can just keep the video rolling. But I'm going to give you some dead air so you can catch up with me if you're keeping track. Okay, we're going to continue with this if statement stuff, and then we're going to talk about a little bit about string comparisons. So notice that this equals Bob doesn't seem to be working. And let me explain to you a little bit, and then we're going to add some code and fix this. What this equals does is this double equals compares this. It compares one object versus the next. Now, what we probably need to do is we need to use, rather than looking to see if the objects are the same, we need to look at the values. So put in, how about this, n1, and then put in dot equals. And so let's see if the value for n1 equals to Bob. So we're not looking at the double equals, which looks to see if they're the same object, but we'll use the equals function that looks at the value. And this seems to work. We have Bob is in the house. So if you want, you could get rid of this debug stop. And again, I'm showing you how you can build these programs. You put debug stops everywhere. And we're just going to change this if statement for these other two if statements. Pardon me. We're going to augment the process names function to have these two more if statements in them. Where the second one is going to look to see if let me do this again one more time. Let me grab these lines of code. There we go. And if the second equals, we're going to put in Cassie. We'll say Cassie is in the house. And the third, we'll put if n, this will be n2, right? And this third will be if n3 equals, again, Fred. We'll put in Fred is in the house. All right, so if I run this, I should be able to see, again, Bob is in the house, Cassie is in the house, Fred is in the house. And there we go. Bob is lame, but this class is cool. Again, it starts here, and then we're passing in Bob, Cassie, and Fred. And then we're calling the method process names. And then within process names, we have an if statement. If n1, if the first name is equal to Bob, Bob is in the house. If n2 is equal to Cassie, Cassie's in the house. If n3 is equal to Fred, we have Fred in the house. Now, this is about as far as I want to go with Java. At this point, you know how to write a Java program. You can go into the Java sandbox here on www.compiledjava.net, and you could write rudimentary Java code. You could debug it. You have the concepts of, like, for example, if I asked you a question, what method is the starting point for a Java program? And if I said, is it process names, true or false? You would say false. Process names is not an entry point of a Java program. And then I would say, for example, like I said, there's going to be a couple of things on the final, such as true or false, is the main method the entry point of a Java application? True, it is. I would also say true or false, all Java programs are written as class files or blueprints. And you would say true. Yes, they are. Another question. Are you allowed to write your own methods in Java? Well, we did. We wrote one called process names. True. You're allowed to write your own methods or functions in Java. True or false? Are you allowed to pass parameters into a Java program? True. Yes, you are, because that's what we're doing right here. So these are the kinds of questions that you're going to be responsible for. Now, I know what I said before. You're not going to be responsible for this. I'm talking about some of the obscure things, such as the public versus private versus friendly, and arrays and all that other stuff. I'm not going to ask you that, but I can think of 10 true or false questions that you should be able to answer here. Such as, is Java an OO program? Yes, it is. True or false? Yes, it is. I think we covered 5, 6, 7 of them, so that's about good. All right. Anyway, thank you so much for your time. Thank you for watching this wherever you are, on your tablet, if you're on the train, or if you're driving, looking at your phone. Hopefully you're not looking at this while you're driving on your phone. But thank you for taking this class remote. Again, as I mentioned at the beginning of the semester, we're going to have these from time to time. Now, you know how to find me. I'm available in cyberspace just about all the time. I'm very text friendly. If you need me, send me a text message. We'll work out what you need. We either do things, I do Skype, I do Blue Jeans, I do WebEx, I do Adobe Connect, I probably forgot a few of them in there. Anyway, I do all of them. So we could do that, or if you need me to meet you on campus, either in the quad or in our classroom, I'll be willing to do that too. You are going to get a lab after this, but it's going to be very simple. If you've been awake during this virtual class here, you already can do your lab. Again, some of you are already seeing that if you kind of follow along with the virtual classes and you come to class and you look at the lecture, the labs are easy. They kind of are, because I don't really go really outside of what we're teaching here. I don't make them easy on purpose, but if you don't follow along, they're going to be more difficult. You're going to spend a lot of time Googling things, when if you just watched an hour video, I kind of cover all of them. So thank you again very much. I'll see you guys in person very shortly, I'm sure. And you guys have a great rest of the day. And as I famously say, I am finished with new material. Have a good day. Bye-bye.